Assalamualaikum warahmatullahi wabarakatuh and good afternoon. Last week we already discussed on the subnet mask IP planning. So now for this week we're going to look into the VLSM variable length subnet mask, which is another type of subnet masking or subnetting. So what's the difference between classful and classless network? So classless network is defined as the VLSM, while classful network is for example, class A, class B, class C. It is called classful network. So with increasing of complexity of network and decrease in IP addresses, it become obvious that classful networking costs waste valuable IP address. For example, if you use class C network, you have 255 maximum hosts. However, if one local network here only have few hosts required, for example 10 or 20 computer inside this local network, so it's a waste of IP address if you use class C. So that's why we go to the classless network using the LSM, variable length subnet mask, so where we can use different subnet masks across the network for the same class of addresses. So if you look at here, it uses /28, and here suddenly you use /30 subnet mask, and then over here it uses /24 subnet mask. So we can use different subnet masks across the network to efficiently use the IP address, assigning IP address. So this is another example for the VLSM. For example, subnet 172.16.14.0/24 is divided into smaller subnet, which is go to /30, and then further subnet one of the unused /30 subnet into multiple /30 subnet. So this is an example. So you can use different subnet masks for each local network depend on the required host. For example, over here is only has 18 hosts, so we can define the subnet mask so that it's just required the minimum the minimum value of the host required, and we can use different subnet masks across the whole network. So how do we want to calculate the VLSM? So this is just an example comparison between subnetted address and VLSM address. So if you look at this subnetted address, the the purple color here is the subnetted range, and we know that this is class B because it started with 172. So the great divide is over here and the small divide should be over here, and the this bit here is the host. With VLSM, basically we divide another part of the host to be the VLSM subnet. So this is the example. So we have a network range, we have a subnet range, and then to efficiently use the IP address, we subnet the subnet using the VLSM. So let's look into an example. So this is the first example of VLSM, how we want to assign an IP address if we have this kind of network in figure 2.2. So the first thing, I think there's one information that is not given, which is the subnet address. So I'll just write it here: 192.168.1.0/27. So basically from this subnet address, we know that this is class C with a subnet mask of /27. So the subnet mask should be like this lah, /27. So this is 27, where the last bit here, 0 bit here, is this is the host. Okay, so from here we know that the host is here, over this red dotted here, and we also know that this is the subnet range, which I put a blue color. Blue color is not green color, and the others is the network range. So the network range is black, green is the subnet, and red is the host. So from here we know that the total host is 2 power of 5, so should be 32 hosts. So in order to assign the IP address using VLSM, we first need to identify the largest host in the network. So for this example, we have this host here, which is 29 hosts, the largest one, and we need to add another IP address. We need to consider another IP address, which is the router interface over here, which is connected to the cable. So for this interface, we also need to assign an IP address. So basically for this network we need 30 IP address. So because of that, we can use /27. So 30 hosts, 30 IP address plus 2 IP address which we cannot assign to any host, which is the network address and also the broadcast address. So the total is 30 IP address required for this local network. So for this network, you can write down the IP address, the range of the IP address, which is 192.168.1.0/27 to 192.168.1.31/27. So we can use /27. That's why I added 32 IP address. So from 0 to 31. So the next step to assign an IP address for this network, we need to find the second largest host, which is these two lah. So we can choose any from these two hosts. So we'll start from the bottom. So from here we have 20 hosts plus 1 interface, router interface 21, and network address and broadcast address, which total of 23 IP address required for this local network. So 23, so we can still use, we still need to use /27, which is 32 hosts maximum. We cannot use /28 because for /28 the total host we can occupy is 16, so cannot. So that's why we still choose slash 27. So for this host, for this local address, should be 192.168.1 dot 32, because here is 31, so we need to continue the next local network to with 32 slash 27 until 192.168 dot 1 dot and added the maximum total host that we can put at 4 slash 27, which is 32 hosts. So here we get 63 slash 27. Okay, sorry. And then next is here, this local network, the same as this one. So 192.168.1.64, because we started with, because at this local network it ended at 63, so we need to start at 64 slash 27. So until 192.168.1.95 slash 27. Okay, now we will look at the fourth largest host, which is 13 hosts here, this local network, sorry. So for this local network, because it uses 13 hosts plus one routing interface and another network address and broadcast address, which total of 16 IP address required, so we can use basically slash 28 subnet mask. So for slash 28 subnet mask, so the total host is 2 power 4, which is 16. So the same number for this local address that requires 16 IP address. So that's why we use slash 28 subnet mask. If we use slash 27 subnet mask, the total host is 32 hosts, which we will waste 16 IP address. So that's why we use slash 28, which is fit with the local address here. So for this local address, we can write it down 192.168.96/28. The range, this is the range 192.168. Sorry, here it should be dot one. So you plus the 16 hosts here, 111/28. So this is the IP address for this local IP address range for this local network. So if you look at this, it uses different subnet masks for this entire network. And for this for this entire network, we need also to assign an IP address for this connection, because this connection has two interface, router D interface and router A interface, and all of this connection or cable need to be IP address, need to assign the IP address. So for this connection here, require two IP address for the interface and network address, and plus the broadcast address, which is we required 4 IP address. So for 4 IP address, we can use /30 subnet mask. So /30 means there's 2 bit here is the host, which we can say the total host should be 2 power of 2. So the total host should be 4 hosts. So it fits with this connection here, and all this connection router B to router D and router C to router D. So now we need to assign the IP address for the connection, router connection. So for this connection, we can assign as 192.168.112/30. So this is the range. So until 192.168.1. So we plus 4 hosts, which is 115/30. The same goes for this connection here, 192.168.1.116/30 until 192.168.1.119/30. And the last connection is over here, which is 192.168.1.120/30 until 192.168.1.123/30. So now we already assigned all these connection IP address for all the local network for entire network that shown in this figure. I hope you understand. So maybe we can look another example. So for this example, we have this figure network with 1, 2, 3, 4 local network. It's also given a subnet address, which is 192.168.10.0/25. So /25 here is the subnet mask, right? In binary is 1, 2, 3, 4. The last 7 digit is the host. So this is the host, put it in red color, and we know that this is C class, and this 1 bit here is the subnet. So for this subnet mask, we know that the total host is 2 power of 7, which is 128 hosts. So first, from this network, we need to identify which is the largest network here. So here This is the largest network, and the second one is this, and third one is this, and the last one is should be this one. So we start with the largest and continue downward. So for this local network, we have 125 hosts plus the interface of the router here, 126, and need to add another two, which is the network address and the broadcast address, which require 128 IP address. So for this, we need to use /25, which is the maximum here. So for this range, we can write it down as 192.168.10.0/25 to 192 sorry 168.10 dot. So total is 128. So plus 128, we get 127/25. So basically, this is the range for this local network. And then next, we need to start with the second largest host, which is this one. So we can, because this is 60 hosts, and then plus the interface and the network and broadcast address. So for this local network, it requires 63 IP address. So we don't have to use /25, because /25 it can go to up to 1 to 8 hosts. So we can use /26. So /26 should be the total host should be 2 power of 64 hosts. So it's nicely fits here for this local address, which requires 633 IP address. If you use /25, it will waste up to 65 addresses. So that's why we choose /26. So for this local network, we can write it down here as it's better to write it over here. 192.168.10.128/26 until 192.168.10 dot, so plus 64, we get 151/26. So this is the range for this local network. Sorry, this is 191, not 151. Okay. The next is the largest host. The third largest host is this network. So we need to assign the IP address over here. So 28 plus the interface, router interface, plus the network and broadcast address. So it requires 31 IP address. So 31, for 31 IP address, we can use /27. So for slash 27, it has 5 bit for the host, so 2 power 5 we get 32 hosts. So for this range, we can use 192.168.10.192 slash 27 until 192.168.10 dot. So plus 32, we get 223 slash 27. So if you look at this, we already see that there's all this network uses different subnet. So that's why we call variable length subnet mask. And the last one, the local network here is 12. So we can use slash 28. So for slash 28, you use 4 bit for the host, so 2 power of 4. So you'll get 16 hosts max. So for 16 hosts, we can use for this local network 12 plus 1 internet router interface plus broadcast address and network address, so total of 15. So you can use this slash 28. So for this IP address, we can use 192.168.10.224 slash 28 until 192.168.10 dot plus 16 2 3 8 slash 28. So this is the range for this local address. 2 to 4 plus 15. So this is 239. Okay. And the last part will be these three connection between routers. So we start here. So basically for this connection, router B to router C or router C to router E and router E to router B, it needed 4 IP address, 2 for router interface, this one and this one, and another 2 is the network and broadcast address. So we can write down here is 192.168.10.240 slash 30, where 30 slash 30 subnet mask, the total host will be 4 hosts. And similar to this part here, and the last one should be here. Oh, sorry. 192.168.10.248/32 1 slash 30. So that's all. This is how you assign each local network with different subnet. So it depends on the host, and you need to start with the largest host in the entire network. So that's all for this week. So next week we're going to still continue in the network layer. We have a few slides left to discuss and a few topics to be discussed until we will go to the last chapter, which is the physical layer. So that's all for today. Thank you. Assalamualaikum.